Okay, dear students, we will discuss one more question from the physical chemistry, that is the question: in a reaction the initial concentration of the reactants increases. In a reaction the initial concentration of the reactants increases fourfold and the rate becomes 16 times. Rate becomes 16 times its initial concentration. Its initial value given to us. Its initial value. The order of the reaction is we have options are there. If we see the first one 2.0, the second one 3.5, the third one 1.5, the fourth one 2.5. See this question. Yes, we are clear. After reading the question, it is discussion about rate of reaction, that means rate order relation from the topic chemical kinetics. So this is also a question from chemical kinetics. Okay. Now if you read the question, initial concentration of the reactant increases. How many times? 4 times. That time the rate also changes 16 times to that of initial volume. So what is the plan in this one? Is aim of this problem is order of reaction calculation, but taking the two experiments, that means two conditions. One condition is initial condition. Initially, what is the rate? You take that rate is RF, suppose RI. If you take RI, that is equals to rate constant into concentration of something, some reactant, like take A, its power, you don't know, order X, take X. So this is what initially we have noticed. We have assumed this is first equation. But after the conditions changed, once concentration changed, that means the rate of the reaction changed as a final rate. When the K is multiplied with 4 times of the initial concentration is A, 4 times it is 4A, power X you have to take. This is what the given condition. Given condition is like this, it is there. That time, if it is raised 4 times, then what about the rate of the reaction is a final one related to the initial one? If you take it, yes, this RF has become 16 times of the initial value. What is initial value? RI. So if you take that one as 16 into RI, that is equals to K into, if you write A power X, the 4 will come outside as 4 power X will become. Okay. Now as we are very clear that K into A power X, again it will become initial rate from the equation 1. into this 4, you can write it as 2 square, then it will become 2 power 2x is equals to 16 into Ri. 16 into Ri. Like this you can write, then Ri will get cancelled, 16 is remained here. So you want to write 16 as 2 power 4, then you can write 2 power 4 is equals to 2 power 2x, then 2x will become equals to 4, so that x will become equals to 4 by 2, that is equals to 2. Okay, or else here itself you can write as 4 power x, this you can write as 4 square, then x will become 2. So what is x we assumed? X we are assuming as order of reaction. So from this calculation we understood that order of reaction is 2, second order. For this the reaction they have taken in the experiment. Hope you understand the entire information what I have given it to you to in this explanation part of considerations of initial and final rate of the reactions. Thank you very much.